Assalamualaikum. My name is Diyana binti Zuhaidie from 4BKGS1. I would like to present my final year project called Liquid Level Control of Nonlinear Couple Tank System using Linear Model Predictive Control. This is the content of my slide, which consists of 7 sections. The first one is Introduction. The first one is Model Predictive Control. Model Predictive Control, or MPC, is an advanced method that is used to control the process while satisfying an inequality constraint. MPC is a widespread solution that is used in industrial applications since 1980s. MPC possesses many attributes that make it a successful approach to industrial control design, such as the simplicity, do not require complex mathematics, and practicality, as it is often the resolution of problems such as satisfying control or output constraints. The main advantage of MPC is it enables optimization of present time slot while preserving the future time slot in account. This is MPC block diagram. This is the general concept of MPC. It is to determine the future output in order to make future prediction within a time window with certain length called prediction horizon. The reference trajectory is one of the advantages of a predictive control scheme. The reference trajectory denotes a first-order exponential curve used to make a gradual transition to the desired set point value. In this step, the relation between unknown control inputs and future outputs is determined. Next is couple tank system. This is the schematic diagram of couple tank system. It is a computer control tank system that is used for liquid level control. There are two major applications for this couple tank system, which is SISO, single input and single output, or MIMO, multi-input, multi-output. The control objective is to maintain the liquid level in tank 1 and tank 2. The process variable is the liquid level. The set point is desired liquid level in tank 1 and tank 2, and the manipulated variable is the pump voltage. This is the block diagram of couple tank system. To achieve the control objective, the liquid level is measured by the capacitive probe and transmit the signal as an electrical signal to the controller. The controller will give a controller output signal to the final control element to impact the process. This closed loop will be repeated till the actual liquid level achieves the same value as the desired liquid level. Next is the problem statement. The liquid balance in tanks and the flow between tanks is a fundamental problem in the production industries. The performance of PID is not satisfying, as many studies have been made where it still has percentage overshoot. So, MPC is proposed in this project to obtain minimum percentage overshoot. Next is the objective. The objective of this project is to implement a new interface for couple tank system and software to obtain a model for couple tank system, plus to design a model predictive controller for couple tank system. Next is the scope. The scope of this project is only SISO process is considered, which is tank 1, where the maximum liquid level is 30.8 cm and the lowest liquid level is 5 cm considered in this project. The maximum and minimum voltage pump considered in this project is 2.15 volt and 1.65 volt respectively. This project used MATLAB R2019B for simulation purpose and used an ideal model predictive control. We will move on to the next section, which is methodology. This is the project flowchart. The first phase is interfacing couple tank system with Arduino Uno. This is the schematic diagram of connection between couple tank system and Arduino Uno. This is the input data that we have, which is the voltage pump versus time. This is the table for voltage and time taken applied, and this is the output data, which is the liquid level. Next phase is the couple tank modeling for transfer function. This is the system identification loop. This is the best fit obtained for this project, which is 84.39%, which considered valid. And this is the transfer function obtained in this project that is used afterwards. Next phase is PID controller design. This is the block diagram of couple tank system with PID controller. This PID controller is designed by using PID tuner application. By default, the response time is average and the transient behavior is slightly too robust. And after tuning, the response time is slightly slower to reduce the percentage overshoot, and the transient behavior is more too robust. After PID controller design is valid, then we move on with MPC controller design. This is the block diagram of couple tank system with MPC controller. Instead of using transfer function model, we convert it into state space model. This is the state space model obtained and will be used in this project. Before tuning the MPC controller, it has given a sample time as 1, prediction horizon as 10, and control horizon as 2. The performance tuning, closed loop performance is average, neither robust or aggressive, and the state estimation is average too, which is neither slower or faster. For tuning, we set closed loop performance to aggressive. Next, we change the prediction horizon NP equals to 20 and 40. Next, we change the control horizon to 5, and we set the prediction horizon to 20, control horizon to 5, and lastly, we change the prediction horizon to 40 and control horizon to 5. Next section is the result of this project. The first one is the performance comparison before and after tuning the PID parameters. This is the set response before tuning PID parameters, and this is the set response after tuning PID parameters. This is the table for comparing the step response characteristic of before and after tuning the PID parameters. The rise time after tuning is much more slower compared to the before tuning, as we set the response time too slow. The settling time is faster than before tuning, and the percentage overshoot of after tuning has 0.0496%, which is much more lower than before tuning, which has 8.13%. Next is the comparison between before and after tuning MPC parameters. This is the step response before changing MPC parameters, which is a prediction horizon equals to 10 and control horizon equals to 2. Next, this is the step response after changing MPC parameters with prediction horizon equals to 20 and control horizon equals to 5. This is a table for before and after tuning the MPC parameters. As we can see that the rise time and settling time for after tuning is slightly faster than before tuning, and the percentage overshoot is slightly higher, which is 0.008% of after tuning. Next is the performance comparison between PID and MPC controller. This is the block diagram of couple tank system with different controllers combined in one simulink. We have a couple tank system without any controller. Next, we have a couple tank system with MPC controller and we have a couple time system with PID controller. This is the step response of couple time system with no controller, PID controller and MPC controller. This is the performance comparison of step response characteristic of couple time system without controller, PID controller and MPC controller. First, for rise time, as we can see that the MPC controller has the fastest rise time, which is 0.7009 seconds. Next, for settling time, the without controller has much more faster, which is 1.3386 seconds, and PID controller has the slowest, which is 13.067 seconds, and MPC has 2.9799 seconds. Lastly, for percentage overshoot, the couple time system without controller has much more higher percentage overshoot compared to PID and MPC controller, which has 0.4102%, and PID controller has 0.0496%. Even though percentage overshoot of PID controller is considered as minimum, but MPC controller has the lowest percentage overshoot among three of them, which is 0.008%. This has proved that the couple time system with MPC controller has much more better performance compared to without controller and PID controller. The conclusion of this project, performance comparison of PID and MPC controller is done. Lastly, it has been proved that model predictive control has a better performance in terms of faster rise time, settling time, and has a very minimum overshoot percentage compared to PID controller. That's all for me. Thank you.